Hi, I'm Marin Still, and this morning I walked into my kitchen with a very specific purpose. I know I had one. It was clear. It was important enough that I got up from what I was doing and physically moved my body from one room to another room to accomplish it. And then I stood in the kitchen for a full 15 seconds, looking at the refrigerator, looking at the counter, looking at my own hands as if they might contain a clue, and thought, what did I come in here for? Nothing. Gone. Completely erased. I walked back to where I started. Immediately remembered. Walked back to the kitchen. Got it done. Felt mildly insane. If this has never happened to you, you are either very young, very lucky, or you are not paying attention. Because this happens to virtually every adult human on the planet, multiple times a week, sometimes multiple times a day. And nobody talks about why it happens. Because the honest answer is so strange and so revealing about how your brain actually works that it is almost embarrassing. Hi, I'm Marin Still, and what I just described has a name. Researchers call it the doorway effect, and the reason it happens is not that your memory is failing. It is not that you are getting older. It is not a sign of anything wrong with you at all. It is your prehistoric brain doing exactly what it was designed to do, in a world that no longer exists. Stay with me. It gets weirder. Let's start with the science of what is actually happening. Because the doorway effect is not folklore. It is a documented, replicated, peer-reviewed phenomenon that has been studied seriously for over a decade. The psychologist Gabriel Radvansky at the University of Notre Dame is the researcher most closely associated with the doorway effect. In a landmark 2011 study published in the Quarterly Journal of Experimental Psychology, Radvansky and his colleagues designed a series of experiments to test whether moving through doorways specifically, as opposed to simply walking the same distance through open space, caused memory impairment. The results were unambiguous. Participants who walked through a doorway forgot significantly more than participants who walked the same distance in an open space. The doorway itself was the trigger, not the distance, not the time elapsed, not the cognitive load of the task. The transition through the threshold. Radvansky called this the event boundary. The brain, he found, organizes memory not into a continuous stream, but into discrete episodes, chapters, essentially. And a doorway signals the end of one chapter and the beginning of another. When you walk through a door, your brain concludes the previous episode and begins compiling a new one. The contents of the previous episode, including whatever you were thinking about when you decided to get up, get filed away. Archived, no longer immediately accessible, which is why walking back to where you started works. You re-enter the physical context of the previous episode, and the memory becomes accessible again. You did not forget, you filed it, in the wrong room. Now here is where it gets genuinely interesting. Because Radvansky's finding raises an obvious question. Why would the brain do this? What is the evolutionary advantage of a memory system that resets itself every time you change physical location? The answer requires going back a very long way. Back to a world where every transition between environments was a genuine threat assessment moment. Imagine your ancestor leaving the cave, not going from the kitchen to the living room, going from a known, familiar, enclosed space where the threats are understood and mapped, into the open, where anything could be waiting, where the entire sensory landscape is different. Different light, different sounds, different smells, different temperature, different spatial relationships between yourself and potential danger. In that world, what your ancestor needed most at the moment of crossing the threshold was not to remember why they came outside. What they needed was a completely fresh threat scan, a wiped slate, total present moment awareness of the new environment they had just entered. The neuroscientist Ayla Fiete at MIT's Brain and Cognitive Sciences Department has studied the neural mechanisms of spatial memory and context processing, and what her research reveals is a brain architecture built for exactly this function. The hippocampus, the brain structure most associated with memory formation and retrieval, is exquisitely sensitive to environmental context. It does not simply store memories, it stores memories tagged to specific contexts. And when the context changes dramatically, the hippocampus effectively begins a new recording session. In plain English, your brain does not have one continuous memory, it has a collection of context-tagged episodes, and context shifts trigger episode boundaries. For your ancestor stepping out of the cave, this was survival technology. The brain that wiped its working memory at the threshold and started fresh was the brain that noticed the predator crouching in the grass. The brain that held onto its previous thoughts, I was going to get that sharp stone, let me think about where I left it, was the brain that got eaten while distracted. Your memory system was not built for linear task completion. It was built for survival in an environment that changed constantly and dangerously. The cognitive neuroscientist Eleanor Maguire at University College London, who has done landmark work on hippocampal function, including her famous study of London taxi drivers showing that spatial navigation expertise physically enlarges the hippocampus, argues that the deep link between memory and spatial context is one of the most ancient and fundamental features of the human memory system. It did not evolve to help you remember grocery lists. It evolved to help you navigate and survive complex, changing physical environments. And here is the kicker. Radvansky's team extended their research in a particularly devious direction. They asked, does the doorway effect work in virtual environments? They built a series of computer-simulated rooms and had participants walk through virtual doorways while trying to remember objects they had picked up. The doorway effect was present in virtual reality too. No physical movement, no actual change of location. Just the visual representation of passing through a threshold. Enough to trigger the episode boundary. Enough to cause forgetting. Which tells you something important. The trigger is not the physical act of moving. The trigger is the perception of context change. Your brain is scanning for environmental transitions, and when it perceives one, even a simulated one, it executes the threshold protocol. The same mechanism that saved your ancestor's life when leaving the cave is now firing when you walk between your kitchen and your living room. When you switch tabs on your browser, when you look up from your phone, when you stand up from your desk to go get something from the other room. Every perceived environmental boundary is a potential episode transition. Every episode transition is a potential memory wipe. And here is the modern slap. Because I want you to think about how your life is designed right now. How many times a day you move between spaces. How many browser tabs you have open. How many conversations you are having simultaneously across different apps. How many times you pick up your phone, are pulled into its context, put it down, look up, and cannot quite remember what you were doing before. Every one of those transitions is an event boundary. Every one of them is your Pleistocene brain executing the threshold protocol, wiping the previous context, scanning for threats in the new one. The cognitive psychologist Larry Rosen at California State University Dominguez Hills, who has spent decades studying the cognitive effects of technology, found that the average adult now switches between tasks or screens every 19 seconds. 19 seconds, the average. Which means the average adult human is triggering event boundaries at a rate that would have been biologically impossible for most of our evolutionary history. Your brain's context-switching system is running at a frequency it was never designed to sustain. And you wonder why you walked into the kitchen and forgot why you came. You did not forget, you filed it. In a brain that was built for a world of slow, meaningful transitions between genuinely different environments. A brain now navigating a world of constant, rapid, artificially constructed context changes every 19 seconds, all day long. Your ancestors stepped out of the cave and forgot what they were thinking about. They scanned the savannah, found it safe, and then stood there for a moment thinking, what was I coming out here for? And then they remembered, because there was only one reason they ever left the cave, and the savannah gave them time to recover it. You walked into the kitchen. Before you could recover the thought, your phone buzzed. New context, new episode, new wipe. The cave was only one door. You have 17. Hi, I'm Maren Still. And now you can never unknow this.